Okay, welcome everyone. This is 18.4 on special right triangles. We have two special right triangles we're going to talk about. They're special because of their angle measures. Okay, the first special right triangle that we're going to talk about is it's called a 45-45-90 triangle. And it's called a 45-45-90 triangle because that is the angle measure. Okay, 45 plus 45 plus 90 is 180. So this triangle works. If it's a 45-45-90 triangle, then I automatically know that this triangle is an isosceles triangle, correct? Because these angles are congruent to each other, okay? And if the angles are congruent to each other, then I know automatically that the sides opposite these angles are congruent to each other. So I'm going to label this as A. Okay? A as in apple. So if this side here across the 45-degree angle is A, the other side is also A, okay, across the 45-degree angle. And across the 90-degree angle, it's always going to be A square root of 2. That's always going to be your ratios of the sides. A rad 2. A square root of 2. Okay? Yeah. And I have a special way of kind of putting this in a graphic organizer, which I want to introduce right now. I'm going to make a tic-tac-toe chart. Okay, like that. And then on the first row here, I'm going to put the angle measures, 45, 45, 90. Okay. On the second row here, I'm going to put that special ratio of the sides. So across the 45 is A. Across the 45 is A. Across the 90-degree angle is A squared root of 2. Okay? These first two rows I put there because it does two things. First thing it does is it organizes my thoughts. Okay? Organizes what's in my brain and put it on paper. The second thing it does, if you keep on writing this out when we are doing our problem set for this section, guess what happens? You guys are keep on writing this, right? 45, 45, 90, A square root of 2, A square root of 2. And then eventually it's just going to be stuck in your brain, right? And you're going to memorize it. So that would further help you guys out. And this is a big topic, honestly, in this class, in your next class, and in pre-calculus, calculus, and so on and so forth. Okay? In pre-cal and calculus, it's actually second. It's already like a given statement that you guys already know it. Okay? So if you guys memorize it now, then later on, it's going to be like, oh, I know this. Yeah. And you're going to have an easier time when it's introduced to you later on. And this last row here is kind of reserved for when I do problems. Okay, you're gonna have some side lengths that you can put in there. And we'll fill out this last row when we do some problems. Okay? So that is the ratio of the sides. Across the 45 is A, across the other 45 is A, across the 90 is A squared root of 2. Okay? The next special right triangle that we have is called a 30-60-90, because that is the angle measures again, the 30-60-90 triangle. And the ratio of the sides work out as this. Across the 30-degree angle, that side is my A. Okay? across the 60-degree angle, that side is a square root of 2. Oh, sorry, not 2, of 3. A square root of 3. All right. And then across the 90-degree angle, that side, my hypotenuse, is going to be 2a. All right. So again, if I tic-tac-toe chart this, right, my first row, 30, 60, 90. The row or the next row is going to be across the 30 is a, across the 60 is a square root of 3, across the 90 is 2a, and the last row is basically reserved for counting. Okay. All right. So for example, let's look at this first one. Okay, let's do an example problem here. Okay, I'm gonna make up a value. I'm gonna say that this side here is 10. Okay. If this side here is 10, then I know across the 45 is 10. So A equals 10, or you can see here A equals 10, right? Both places. Then this A is also 10, right? So then this is 10. And then A squared of 2 is, if A is 10, then A squared of 2 is 10 square root of 2, right? This is a really basic problem. 10 square root of 2. So now I know the ratio of the sides. Cool? Yeah? Make sense? Yeah? Okay. Yeah. Each side. It's a right triangle always. So you can use the Pythagorean theorem to figure this out. If I label this side as 10, letter-wise, it's always going to work out as 1, 1, 1 square root of 2. It's always going to be yeah. So across the 30 is 1. Across the 60 is 1 square root of 3. And then across the 90 is 2 times 1, which is 2. Yeah. So that's always going to be the ratio of the side. Okay. All right. So we just did an easy problem here. A little difficult problem would be like this one. Okay, notice that 10 now is my hypotenuse, right? So here, my first step would be to build out a tic-tac-toe chart. It's a 45, 45, 90. I know across the 45 is A. I know across the 45 is also A. Across the 90 is going to be A square root of 2, right? Okay, that's my ratio of the sides, correct? Across the 45 is A. Across this 45 is A. Across this 90-degree angle is A squared of 2. All right? So now I'm given that this side is 10, correct? So if that is 10, I'm going to put it here. Yeah? Now I know that A squared of 2 equals 10. And one of my A value is X, so I'm just going to put that X here. Okay? And honestly, this is also X, because if that is X, if A is X, then A is X, right? We have to solve for A. Now, looking at this, because they're equal, right? A squared of 2 equals 10. Okay, does that make sense? Yeah. So if a square root of 2 equals 10, then I'm going to solve for a by dividing by square root of 2 on both sides, right? So that a equals 10 over square root of 2, but I cannot leave it like this, okay? Because there is no square root in my denominator. So I'm going to open it up to the class. How do I get rid of the square root? Or how do I cancel out a square root? Yeah, you cancel it out by multiplying it by square root of 2 over square root of 2. Okay? When we do that, and you multiply it across, 10 times square root of 2 is 10 square root of 2. Square root of 2 times square root of 2 is, what is 2 times 2? 4. So you can say that it's square root of 4. Square root of 4 is 2. So I have 10 square root of 2 over 2. Right? But the 2 can cancel out with the 10, make 1 and 5. This answer, my a value, is actually going to equal 5 square root of 2. Okay? So now I know that my a value is 5 square root of 2. This guy up here is 5 square root of 2. 5 square root of 2. So x is actually equal to 5 square root of 2. Does that make sense? No, it's a 5 square root of 2. What? What was your question? Yeah. Oh no, a 5 square root of 2 is not 2.5. It's 1.41 is square root of 2 times 5. 7 point something. Yeah. You don't have to put it in a decimal. You don't have to put it in your calculator. You can just leave it like this. Okay? Questions? Any other questions? Simple? Yeah? Yes? Ish? That's the hardest one here, though. If I give you, or if your problem gives you a square root of 2 as a whole number, this is the difficult math, right? That's as difficult as it gets for these type of problems. Okay, in a 45, 45, 90 triangle. Okay? So the next one, I have 3 of them, but all the ones that I give you are in different spots. Okay, so I want to go over one of each. So this is a 30, 60, 90 triangle, correct? So right off the bat, I am going to put my tic-tac-toe chart. 30, 60, 90. I know across the 30 is A. Across the 60 is A square root of 3. Across the 90 is 2A. Okay? So across the 30 is A. Across the 60 is A square root of 3. And then across the 90 is 2A. That is the value of the side, okay? Compared to one another. All right? So across the 30 is 5. So automatically, I know my A value, right? A equals 5. Correct? Okay. Across the 60 is A square root of 3. So that's X, I mean. And then across the 90 is my Y that I need to figure out. I need to figure out my X and my Y, right? So if a is 5 square root of 3, what is a square root of 3? Or I'm sorry, if a is 5, what is a square root of 3? 5 square root of 3. What if a is 5? What is 2 times a? 10. That's it. So I know my x value is 5 square root of 3. I know my y value is 10. You're done. Right? Simple? Okay. Next one. I give you 12. Okay, so again, I'm going to start off with my tic-tac-toe chart. 30, 60, 90. Across the 30 is a. Across the 60 is a squared of 3. Across the 90 is 2a. These two rows never change. Okay, they will never change. They will only change if the triangle changes. Okay, if it's a 45, 45, 90, it's a squared of 2, right? Okay, so across the 90 is 2a, or 12. I'm sorry, across the 90 is 12. So across the 90 is 12. Across the 30 is x. Across the 60 is y, right? So if 2a equals 12, now I know 2a equals 12. What is a? 6. So a squared root of 3 is 6 squared root of 3. That's it. Simple. Yeah. Now the most difficult type of problem that I can give you is this last one here. Why is it most difficult? Because the square root, right? You know across the 60 is a squared of 3, right? And that is the most difficult math that you're going to do on these problems here. So let's go with 30, 60, 90, a squared of 3, and 2a. Across the 30 now is x. Across the 60 is 9. Across the 90 is y, right? Now I know that a squared root of 3 equals 9. Okay, so I have to do a little bit of math. A squared root of 3 equals 9. I'm going to divide by square root of 3 to cancel out those guys. So that's a, right? Equals 9 over square root of 3. But again, I cannot have a radical in my denominator. So I'm going to multiply it by square root of 3 over square root of 3. Right? Multiplying it across, that's 9 times square root of 3, which is 9 square root of 3, over square root of 3 times square root of 3, square root of 9. Let's do it like that. So 9 square root of 3 over 3, right? Square root of 9 is 3. And then you can see that the 9 cancels out with the 3, make 1 and 3. So we have 3 square root of 3. Yeah. Cool. So my a value is 3 square root of 3. So this is 3 square root of 3. If a is 3 square root of 3, what is 2a? 6 square root of 3. So that's my y value, and that's my x value. Cool? Yeah. So the numbers are going to change, and you're just going to deal with it. Make sure that you guys write out these two rows. Okay? Just honestly, just to get it memorized. Okay? If you guys do it now, promise me or I promise you that life will be easier later. Okay? All right? Questions on that? My next little bit for right now is called the Pythagorean triplets. Okay? You guys all know that in a right triangle, my two legs are A and B. My hypotenuse is C, right? Okay? And we also have something called the Pythagorean theorem, where it's A squared plus B squared equals C squared, right? And if I give you guys two of these sides, you can use this formula, this theorem, right, to figure out the third side, correct? You guys all do that. We're good with that, okay? I am going to just give you some tips, okay? And these are called the Pythagorean triplets because the numbers will always work out that way, okay? So for example, let's do this first one here. If I know that the first two sides is going to be a 3 and a 4, like 3 inches and 4 inches, the hypotenuse, without even doing any math, is going to be 5. Because it's a Pythagorean triplet. Okay? That makes sense? Yeah? You could always refer back to the Pythagorean identity. Or, sorry, got my Pythagoreans all mixed up. Pythagorean theorem. Right? You can always do this. 3 squared plus 4 squared equals C squared. What's 3 squared? 9. What's 4 squared? 9 plus 16 is? Don't look at me like that. 25, right? Square root of 25 is 5. It'll always work out that way. Okay? It's always going to be a 3, 4, 5 triangle. All right? Next one. If you see a 12 and a 13, right? Your hypotenuse is 13. Your one of the sides is 12. The next side, without doing any math, is going to be 5. Okay? It's going to be 5 again. Because look, what's 13 squared? It might be a little harder, but you guys got it. 169 minus, what's 12 squared? 144. What's 169 minus 144? 25. Square root of 25 is 5. Okay? You could do all that math. I'm just giving you tips. Does that make sense? Yeah? The next triplet is a 7, 24, 25. So again, if you see a 7 and a 25, you automatically know that the last side is 24. If you see a 27 and a 24, you know that last side is going to be a 25. Does that make sense? Without doing any math. Okay? You can just refer back to, hey, it's a Pythagorean triplet. Yeah? And the last one is 8, 15, 17. Okay? The sides will always work out. If you see any of these two values, it's always going to be that third one that's not there. Okay? Or any multiples of it. All right? Or any multiples of it. So meaning, if I have a triangle like this, okay, there's my right triangle. And let's say this is a 9. And let's say this is a 15. What is that side? Without doing any math. I just want the class to kind of guesstimate or think by themselves. It's going to be 12. Okay? Because This is a 3, 4, 5 triangle times 3. Does that make sense? 3 times 3 is 9. 5 times 3 is 15. So this has to be 4 times 3, which is 12. All right? So during this problem set, have this list, have the two special right triangles right next to you, right? And try to work it out. Cool? Questions? That's the lesson for 18.4 class. And I will see you next time.